Hi everyone. Let's solve an optimization problem asking us to minimize time it takes a visitor to get to an island. An island lies 2 miles offshore from its nearest point on a straight shoreline. A visitor is staying at a cabin located 5 miles along the shore from that point. The visitor wants to reach the island as quickly as possible. The visitor can run along the shore at 6 miles per hour and swim at 3 miles per hour. How far should the visitor run along the shore before entering the water to minimize the total travel time? The visitor has 3 possibilities. The visitor can start swimming right away. The visitor can run all the way and then start swimming. Or the visitor can run for a little bit and then swim for a little bit. Let's draw this last scenario. The visitor will run for a little bit and then the visitor will swim for a little bit. The distance the visitor runs will be denoted by x. The distance the visitor swims will be denoted by y. If the visitor decides to swim right away, then x is 0. If the visitor decides to run all the way and then swim, then x is 5 and y is 2. We want to minimize the total travel time. What we want to minimize is the total time spent traveling. And I believe the total time spent traveling is time spent running plus time spent swimming. How can we represent the time running using the variable x? Remember, x is the distance ran. You know a formula that connects the time and distance. You know that distance is given by velocity multiplied by time. For example, when you run 6 miles per hour for 3 hours, then the distance traveled is 18. If you solve this equation for time, you will get that time equals distance divided by velocity, which means time spent running is distance spent running divided by velocity, which gives you x divided by 6. Similarly, the time spent swimming is the distance swam, which is y, divided by the velocity or the speed of swimming, in our case, 3. This is what we want to minimize. This is an equation whose minimum we want to find. What is the constraint? We see a nice triangle here. One side of this triangle is y, one side of this triangle is 2, and the third side of this triangle is 5 minus x. This tells you that there is some relationship between x and y. The relationship is given by, from the triangle now, we see that 5 minus x squared plus 2 squared equals y squared. This is our constraint. The constraint is that there is some relationship between x and y. 5 minus x squared plus 4 is y squared. What I can do here is I can solve this for y and plug it in to my function which I want to minimize or maximize. In this case, minimize. Let's solve the constraint for y. I take square root on both sides and I get that y equals square root of 5 minus x squared plus 4. Let me plug it in to the function I want to minimize, and I get that the total time is x divided by 6 plus, and instead of y, I will write the square root, 5 minus x squared plus 4 divided by 3. This is my function that I will minimize. Let's write it down as f of x. X divided by 6 plus square root of 5 minus x squared plus 4 divided by 3. What are the possible x's you can use? Remember, we said that the smallest x can be is 0. The largest x can be is 5. There's no point for the visitor to run past the point closest to the island. This means that the domain of this function is x's in the interval from 0 to 5. The next step is to find critical numbers of this function. For now, let me just tell you what the critical number is, and at the end of the video, I will show you how you can find it. This way, you will not lose track of the big picture. The next step is to find critical numbers. The critical number is x equal to 5 minus 2 divided by square root of 3. Now let's check if this number gives us the absolute maximum, absolute minimum, or neither on the interval from 0 to 5. I will use the closed interval method for that. I know a critical number inside of this interval. To find the absolute maximum or absolute minimum, I compute the value of the function at 0, at 5, and at a critical number, and I look at which value is the biggest, which value is the smallest. What I need to compute now is the following. I need to know what f of 0 is, I need to know what f of 5 is, and I need to know what f of 5 minus 2 square root of 3 is. I used the calculator to evaluate these expressions. I plugged in 0, 5, and our critical number to our original function, and I got, when I plugged in 0, I got approximately 1.8. When I plugged in 5, I got 1.5. And when I plugged in the critical number, I got approximately 1.41. The smallest number is the one given by the critical number. This is our absolute minimum. If the visitor runs this much, then the total trip will take about 1.41 hours. If you're wondering how far this is, 5 minus 2 over square root of 3 is approximately 3.85. This was the distance ran, which means the units are miles. The visitor must run about 3.85 miles to minimize the time it takes to get to the island. I told you that at the end, I was going to show you how you can find critical numbers of this complicated function. Let me do this on the next page. Let me first copy the formula so we remember what the function was. To find critical numbers, I first take the derivative. The derivative of x divided by 6 is simply 1 over 6. The derivative of the second expression is dividing by 3 is the same thing as multiplying by 1/3. Then I take the derivatives from the inside out. The derivative of 5 minus x is -1. The derivative of the power causes 2 to come down in front of the parentheses. The derivative of 4 is 0, I don't write it down. Finally, the derivative of square root is 1/2 whatever was inside of the square root to the power -1/2. Let's simplify this expression because a few things will simplify. 1/6 stays the same. Then plus changes into the minus thanks to this negative 1. I see that I have 2 and 2 here. Those 2's divide out. In the numerator then, I am left with 5 minus x. In the denominator, I will have a couple of expressions. I definitely have 3 in the denominator. I also will have this expression in the denominator, because raising something to the negative power is the same thing as putting it in the denominator. So I get 3 times square root of 5 minus x squared plus 4. Now I ask myself, are there any x's that make this derivative not defined? And are there any x's that make this derivative equal to 0? And I believe there are no x's that make this derivative not defined. And that is because no matter what x you plug in right here, this number will be at least 0. When you add 4 to it, that gives you a positive number. Square root of a positive number is always positive. You will never get 0 in the denominator. You can plug in any x you wish to this expression and you will always obtain an answer. To determine when this derivative equals 0, I set this equal to 0. When I set it equal to 0 and I move the fraction to the right side of the equation, I will get that 1/6 equals that expression on the right side, 5 minus x divided by 3 roots of 5 minus x squared plus 4. I cross multiply this equation and I get 6 5 minus x equals 3 roots of 5 minus x squared plus 4. I want to get rid of the square root. Let me square both sides. When I do that, I will get 36 5 minus x squared. On the right side, I will get 9, and the square root goes away, and I am left with 5 minus x squared plus 4. Let's multiply the right side. On the left, I get 36 5 minus x squared. On the right side, I will get 9 5 minus x squared plus 36. On the left side, I have 36 of these parentheses. On the right side, I have 9 of them. When I subtract this term from both sides of this equation, on the left side, I will get 36 minus 9. 36 minus 10 is 26, plus 1, 27. So I get 27, 5 minus x squared. On the right side, I get 36. I divide both sides by 27, and I get 5 minus x squared equals 36 divided by 27. Then I take square root on both sides, and I get 5 minus x equals plus or minus square root of 36 divided by 27. I know that square root of 36 is 6, because 6 times 6 is 36. 27 can be written as 9 times 3, and square root of 9 is 3. So this gives me plus or minus 6 divided by 3 square root of 3. 6 and 3 cancel and give me plus or minus 2 square root of over square root of 3. I'm solving for x. What I'm going to do here is I will first subtract 5 on both sides, and I will get negative x equals plus or minus 2 square root of 3 minus 5. And then I multiply everything by negative 1, and I get that x equals 5 plus or minus 2 over square root of 3. We know that x's cannot be more than 5. The domain of our function was between 0 and 5. When I add the square root, I get outside of the domain of my function, which means that the only critical number that I can use here is 5 minus 2 square root of 3.